Find the volume of a solid formed by revolving the region bounded by the curves y equals 2 minus x squared and y equals 1 around the line y equals 1. Ugh, leave your answer in terms of pi. Alright, so this is what's going on here. We have this picture, 2 minus y squared. We're cutting it around here, and rather than spinning it around the x-axis, we're spinning it around here and creating this like weird shape that's going to look almost like a football, an oblong figure. Okay, so we're creating that. And since we're not spinning it around the x-axis, we're spinning it around another thing. We need to kind of use a reimagined version of the disk method. So the disk method is pi whatever squared. Okay, this is slightly different. The disk method around other axes is going to be the integral from a to b of pi, and then we're going to take our function that we're given, which is f of x, subtract the axis that we're spinning it around, which is g of x, and squaring that whole thing dx. So the f of x that we are going to use as our top part and the g of x that we're going to use as our bottom part are going to be these two guys right here. Now, before I can even begin this stuff, I have to find out my limits of integration. So my limits are going to be found by setting 2 minus x squared equals to 1 so I can find out where these two lines intersect. So why don't I subtract 1 to get 1 minus x squared equals 0. Why don't I add x squared so I get 1 equals x squared, square root everything, not forgetting my positive or negative, and my limits are going to be positive or negative 1. Okay, so let's set this god-awful mess up. All right, we have the integral from negative 1 to 1. Let's move the pi out front because I can. That is going to be f of x is 2 minus x squared minus g of x is 1 dx. Okay, don't forget the squared. That becomes pi from negative 1 to 1 of 1 minus x squared squared dx, which before we even integrate can be changed even further by squaring that whole parentheses, which is a perfect square trinomial. So 1 minus 2x squared plus regular x to the fourth, close it, dx it. Now it's time to integrate. Pi is still going to live out there. All right. The integral of 1 is x. And then we have negative 2x squared, which becomes negative 2/3 x cubed. And then we have x to the fourth, so plus 1/5 x to the fifth, with my limits existing at negative 1 to 1. Now we plug stuff in. Pi times 1 minus 2/3 1 cubed plus 1/5 times 1 to the fifth minus pi times negative 1 minus 2/3 negative 1 cubed plus 1/5 times negative 1 to the fifth. Okay, lots of same numbers are going to be repeated, just opposites. All right, pi is still out there. We get regular 1. This becomes 1, so times negative 2/3 is negative 2/3. This becomes 1, so times positive 1/5 is positive 1/5 minus pi. Okay, you're still negative 1. You become positive 2/3, and you become negative 1/5. Okay, common denominators of 15 are going to change that first bracket into 15 over 15. Multiply u by the 5, so minus 10 over 15. Multiply u by the 3, so plus 3 over 15. Minus pi Do the same exact thing. You become negative 15 over 15 times u by the 5, so plus 10 over 15, and times u by the 3, so minus 3 over 15. 15 minus 10 plus 3 is 8, so we get 8 over 15 minus pi times negative, same thing but negative, 8 over 15. This becomes 8 pi over 15, double negative plus 8 pi over 15. Add the 8 pi plus the 8 pi, 16 pi over 15 is going to be our answer. Barf City. Barf City. Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared, y equals 0, and y equals 8 around the line y equals 8. No! Leave your answer in terms of pi. So what we're doing is we're taking a parabola and we're spinning it around 8. And we're going to get this weird oval-looking shape, pill-looking thing when all is said and done. So we are going to use the disk method, but around others, right? So the equation for that, the normal disk method is going to be integral from a to b, pi f of x squared. But since we're spinning this around a different axis, we're going to do f of x, the original equation, minus g of x, and then square that. So very similar, but not completely the same. Okay, so we need our limits of integration before we can do anything. So our limits are going to be found by taking the original equation here, x squared, and setting that equal to 8 so I can find out where x squared and 8 intersect. Oh, no way. This is going to be terrible. Square root, plus or minus, x is going to equal positive or negative 2 root 2. Oh, I hate it. I hate it. But thankfully, over here, we're blocking it off at 0. Okay, so I take it back. So we're not getting like a full pill-looking thing. We're getting half the pill. So think of it as your doctor's telling you to cut your pill in half. It's a half medication. It's how I handle my anti-anxiety meds. So we're going from 0 to 2 root 2 on this one. 0 to 2 root 2. So let's set it up. 0 to 2 root 2. Let's rip the pi out front. We have f of x, which was x squared, minus g of x, which is 8. We're squaring the whole thing, dx. That becomes pi from 0 to 2 root 2. That is a perfect square trinomial, so that becomes x to the 4th minus 16x squared plus 64 dx. Now we're free to integrate. Pi still lives out front. The integral of x to the 4th is 1/5 x to the 5th. The integral of negative 16x squared is negative 16 over 3x cubed. That's going to be a pain in the butt. And the integral of regular 64 is 64x. Your limits are still 0 and that god-awful 2 root 2. But fortunately, that 0 is going to make life a lot easier than having to deal with the other 2 root 2 that I originally thought we had to deal with. Pi is still going to be out there. 1/5 of 2 root 2 to the 5th minus 16 thirds 2 root 2 to the 3rd plus 64 times 2 root 2. Close that off. Minus 0. Why? Well, you plug in 0, you get 0. Minus, you get 0. Plus, you get 0. And then multiply to pi, you get 0. All right. Here comes the fun part. You ready? Here comes the fun part. Pi is still out there. 1/5 is still out there. 2 to the 5th power is 32 times. Root 2 5 times is going to be 4 root 2. Okay, root 2 times root 2 times root 2 times root 2 times root 2 is the square root of 2 twice, which is 2 times root 2, which is where I get 4 root 2. minus 16 thirds, a similar process. Okay, 2 times 2 is 4. No, 2 times 2 times 2 is 8, right? Root 2 times root 2 times root 2 is 2 root 2. Plus 64 times 2 root 2. Fortunately, I don't have to lose sleep over that one. So this becomes pi 1/5 times 128 root 2. I don't know why I put that up there. Let me move that down. 128 root 2. What was that? Minus 16 thirds. 16 root 2. Plus 64 times 2 root 2. (128 root 2 over 5) minus 200 and no, 256 root 2 over 3 plus 128 root 2. Multiply u by 3 over 3, multiply u by 5 over 5, multiply u by 15 over 15. I'm just going to wave my hands around a little bit. Okay, wave my hands around a little bit and just tell you what the answer is. And you're just going to have to trust me on this one. Pi is going to live here. Maybe we'll sneak the pi in right there. But boy, is that awful. Let me write that out one more time. 1024 pi root 2 over 15. When I created this problem, I made a mistake. I didn't want that to be 8. I wanted it to be 4, but I stuck with it, and I hope you stick with me because I love you. Thanks for watching. Find the solution for revolving the region bounded by the curves x equals negative y squared and x equals negative 4 around the line x equals negative 4. Well, boys and girls, this is the disk method around a different axis, and we're not spinning it around the x stuff, we're spinning it around the y stuff. So the formula for that is going to be the integral of pi f of y minus g of y squared dy, where your original equation is going to be f of y, and the axis that you're spinning it around is going to be g of y. Now, in order to find our limits of integration, what we need to do is set these guys equal to each other. So negative y squared equals negative 4. Common sense says, well, why don't we just multiply everything by negative 1, so you get that. Square root both sides, don't forget your plus or minus, and your limits are going to be positive or negative 2. So the equation that we're going to set up is we're going to set up ripping out the pi from negative 2 to 2 of f of y, which was negative y squared, minus g of y, which is minus negative 4, so plus 4, square the whole thing dy. Okay, when you do perfect square trinomial stuff in there, you'll get pi integral negative 2 to 2. This becomes positive y to the 4th minus 8y squared plus 16 dy. Now we can integrate. And that would be into great if we did. Pi, you become y to the 1/5 y to the 5th. That was a close one. Minus 8/3 y cubed plus 16y. My limits are still negative 2 and 2. Now it's a matter of plugging stuff in. Don't make any math errors. You're going to see a lot of repetition because the same numbers are going to be used twice. Just one's opposite of the other. You get pi times 1/5, 2 to the 5th, minus 8/3, 2 to the 3rd, plus 16 times 2, minus pi 1/5, negative 2 to the 5th, plus 8/3, negative 2 to the 3rds, plus 16 times negative 2. What do we have? We have 2 to the 5th is 32, so 32 over 5 minus. All right, let's do this. 8 times 8 is 64 over 3 plus 32. And these numbers are going to be the same, just the opposite versions of that. Negative 32 over 5 plus 64 over 3 minus 32. Okay, common denominator of 15. So we'll multiply u by 3s, multiply u by 5s, multiply u by 15s. Or I could just wave my hands around a little bit and say, I promise you I know what I'm doing. Even though I make little errors, this is what we're going to get. We're at the very end of this, kids. We're like right there at the end. Let me be lazy. I made a lot of videos and my brain hurts. Thank you for watching, though. Love you.